I am Merupa. I am from EC department. My roll number is 2453180401. I am giving seminar in signals and system. My topic is introduction and classification of signals and systems. A signal is a function that conveys information about the variation of physical quantity. It can represent sound, light, temperature, pressure, current, voltage, images, or any measurable phenomena. Mathematically, a signal is usually represented as a function of an independent variable such as time t. Behavior mathematically, a signal is one or more function of one or more independent variables, and this is a signal is it has various applications. It is used in our daily life. You can see the example of x of t equal to sine of 2 pi ft. Sine of 2 pi ft as shown in the figure. The next one is classification of signal. Signals are classified into some types. One of them is continuous and time signal, analog and digital signal, periodic and aperiodic, deterministic and random, energy and power, even and odd, casual and non-casual signals. Continuous time signal. It is a signal that is defined for every instant of time. Example, x of t equals to sine of 2 pi ft. In this figure, we saw the signal. It is continuous at every instant of time. Discrete time signal. It is a signal that is defined only at specific distinct time. Example, x of t equal to sine 2 pi n by capital N. In this figure, we see at some values only it is distinct. It is definable. Whole over the signal is not defined continuously. So this is the discrete time signal. Next one is analog signal. It is a type of signal in which the amplitude can take any value in a continuous range. Example, x of t equals to sine 2 pi t. We can see in this figure. Digital signal in which the amplitude take only a finite number of discrete values. Example, digital audio, computer audio, etc. Next one is periodic signal. It is a signal repeats itself after a fixed time interval. X of t equals to x of t plus t. Example, x of t equals to sine of 2 pi ft. We can see in this figure. A periodic signal. It is a signal that does not repeat itself at regular intervals of time. That does not repeat at regular intervals of time. That is a signal. Example, speech signal. In this figure, we see that it does not repeat at regular intervals of time, so that is a periodic signal. In the above figure, we see periodic signal. It repeats after regular intervals of time. System. A system is a process that can. A system is a process of device that takes a signal as input. Performs some operation on it, and produces another signal as output. Example, y of t equals to 2 into x of t. This system multiplies the input signal by 2. In this, if input is x of t, output is y of t. Next one is like this. Linear and nonlinear systems, which follows superposition. Homogeneity is known as linear systems. Example, 2 into x of t plus 3. Non-linear. It does not follow superposition. That systems is known as non-linear systems. Example, y of t equals to x of t whole square. Time variant and time invariant systems. Time variant. Characteristics do not change with time. Example, y of t equal to x of t minus 2. Time variant. Properties vary with time. Example, y of t equals to t minus x of t. The next slide is about casual and non-casual systems. Casual output depends only on present and past inputs. Example, y of t equals to x of t, y of t equals to x of t minus 1. If you place in place of t equal to 0, we get the present and past inputs, but does not depend on future inputs, so it is causal system. Non-causal. Output depends on future inputs. Example, y of t equals to x of t plus 3. Stable and unstable systems. Stable and unstable systems. The system's bounded input and bounded output is known as stable system. If the system doesn't have bounded output and bounded input, that is not a stable system. Next one is about unstable system. A stable system as example, y of t and x of t. 0.5 x of t. It is a stable system. Unstable system. Bounded input may produce unbounded output. Example, y of t equals to e power t into x of t into y of t. And the next one is about static and dynamic system. Static, another name is memory-less system. Dynamic, another name is uh, memory systems. Memory-less. Output at any instant depends only on present input. Example, y of t equals to 3 into x of t. Memory. Output depends on past or future input values too. Example, y of t equals to x of t plus x of t minus 1. Lastly, we can see some of the applications. Signal. In communication systems, we have some applications. Signals means voice, video, or data. System means transmitters, channels, receivers. Application examples, mobile phones, radio and TV broadcasting, internet data transmission, audio and speech processing, signal, sound waves, speech signal systems, audio filters, speech signals, audio filters, and equalizers, speech recognition, algorithms. Application examples, noise cancellation, headphones, Siri, Alexa, audio compressions, MP3. It is also applied in biomedical engineering. Signals in signals as used as ECG, EEG, MRI scans. System signal amplifiers, filters, image reconstruction algorithms. Applications: heartbeat monitoring, brain signal analysis, medical imaging, CT, MR, EEG, ECG, image and video processing. Signal in image and video processing used as 2D image or 3D video signals, system compression, enhancement, recognition. Application example, face recognition example, Face ID, image filters in apps, video compression like MPEG, control systems, sensor measurements like speed, temperature, etc. Systems as in control systems as used as controls, PID, adaptive. Application example, QC control in vehicles, flight control in aircraft, robotics in automation. It is also used in power systems and electrical engineering. Signal as voltage, current waveforms. A system as used as signal monitoring, fault detection. Application: smart grids, fault detection, transmission line, power quality analysis. It is also used in machine learning and AI. Signal: sensor data, images, text, audio. System is used in machine learning and AI, pre-processing, feature extraction, classification models. Application examples: self-driving cars, motion detection from voice, predictive maintenance. Radar and satellite systems also use signals and systems. Signal, echo or reflected waves for signal use. Signal processing or abstract range or speed system is used. Application examples: weather radar, air traffic control. These have so many examples of signals and systems. Signals represent information classified as CT or DT, analog or digital, periodic or aperiodic, etc. System process signals classified as linear, non-linear, casual, non-casual, stable, unstable, variant, time invariant, so many types. Signals and systems are applied in day-to-day life very prominently. It is used in biomedical, audio or speech communication, image or video, control systems, power systems, AI or ML system, radar or satellite, time series, industrial. In so many slides, in so many uh, uses we have in signals and systems. And thank you, Simon.